volumes, different parameters, intersection volume studies. And the last thing we were doing was limited network study, which is done around a particular facility, a traffic generator, and it is for the whole network. And we need to make two types of countings: coverage counts, control counts. Control are full, coverage are partial, and then we looked at some examples in which we saw how to convert the coverage counts into full counts as well. So we looked at three variations of the example, and we calculated two types of factors: the adjustment factors and the expansion factors. And in one example we used both of them. Now this is another example, a bigger network. So it has 9 stations, which you can see with numbers, and it has one more, the 10th one, which is represented with letter A. So the letter A is the control and the others are coverage. Okay, they have two sets of road tubes. So if they have two sets of road tubes, one of them has to be on control. So one of the road tubes will be on the control point, which is control count, which is on point A, location A. The remaining will be shifted from one location to the next. Okay, so we have only one road tube and we have 9 other locations. So what they have done is summarized in these two tables. The first one gives you the count for location A, and the second one gives you the count for the remaining 9 locations. And the count is done in 3 days, and you can see they have done the counting for 3 hours 45 minutes, then a 15-minute gap, and then another 3 hours 45 minutes, and so on and so forth. Now if you look, why is this gap? It was not in the previous example. It should have been, but it was not given with the data. But if there is a gap, what could be the reason for the gap? The reason is that you are shifting road tube from one location to the other location. Okay, so there is one road tube which is going from location 1 to 2 to 3 and so on and so forth. So you need some time for this shifting. Okay, so the 15 minutes can be used for this type of shifting. I'm explaining this because normally we have discussed that breaks are required in manual counting, and here the question specifically says road tubes. So theoretically shifting is not required, but because of the shifting of the sensors, the road tubes, we need these 15 minutes. Now don't ask me why it was not given the last question, because I don't know. Okay, but here it is, and this is a possible reason for it. So the tubes was shifting at the coverage count locations. What happened to the control count location? I'm taking a 15-minute gap and then giving you the count for the same location. So there is no shifting here. In the first table, there is no shifting. Now why there is a 15-minute gap? The 15-minute gap is there to match the timing of one interval of control with the timing of one coverage location. Okay, so one interval at control is 3 hours 45 minutes, and this is the same interval we are having at one of the coverage locations. Okay, so this matching is important so that you can perform the calculations across all the points in the same way. Okay, so this is why we have the matching, and this is why we have the break in the first table. It's not required. Okay, not in any sense, but the only reason is to conform to the interval between all the locations. Okay, now since there's a 15-minute gap, the first thing we need to do is remove this gap, or fill this gap, not remove it, fill this gap. Now all these counts have a 15-minute gap, right? So how do I fill this 15-minute gap? Tell me, what should I do? So let's say the first value is 3000. Okay, and then there's a gap of 15 minutes between this value and the next value. What should I do to fill this gap of 15 minutes? The first value is 3000, the next one is 2800. What should I do with these values or any of these values to fill this 15-minute gap? Tell me. Yes, anyone. We already did it in chapter 2. There was a question like this. What did you do? Anybody remembers? How to shift it? Yes. Anyone else has any idea? What should I do with this? I have a value which is 3000. See this one. This value is for 3 hours 45 minutes. And then there's a 15-minute gap before the next value. So how do I fill this 15 minutes gap? I need continuous values, right? 8 to 12, then 12 to 4, 4 to 8. So how do I fill this 15-minute gap? It should be 8 to 12, but now it is 8 to 11:45. What should I do?
We need adjustment factor.
No. We don't use adjustment factor here. Or you can explain to me what do we mean by adjustment factor? Like what calculations are you suggesting? And Nazha, what do you mean by converting it? How do I convert it? Tell me. Like, do you have any of you have as a calculation or an equation which you can give me here? How do I make this into 4 hours? How do I make it from 8 to 12? It's very easy. I believe all of you have it in your mind, but if you can just write it here, it will be very good. No, not multiply by 0.25. It will not work. Yeah, tell me. So what do you do with 3000? There's a value of 3000, huh? 4 hours to 8 hours, huh? What are you doing? You are not converting 4 hours to 8 hours. You are converting 3 hours 45 minutes to 4 hours. That's it. So what should I do? Multiplying by 0.25 will not work. So how do I convert the value to the period needed?
3000 over 3 multiplied by 60 plus 25 multiplied 4 by 60.
Can you write it?
23,008. Yeah.
Can you write it? Yes. Okay, good. So yes, the period is so the count is 3000. Okay, the period which we need is 4 hours, right? So multiply by 4. Okay, divide by so yeah, you are missing the multiply by 4. So when you divide 3000 with this value, 3 into 60 plus 45, it will convert the count to per minute. Okay, number of vehicles per minute. Then you need to convert it to 4 hours, so you should multiply by the number of minutes in 4 hours. So what I'm saying here is we are doing this. Yes. Okay, so or simply you can do this. 3 hour 45 minutes means 3.75. 3 hour 45 minutes is 3.75. Okay, now there's a gap for all the values in both the tables. So this step is required for all the values. Okay, so all these 9 values and all these 9 values, okay, of table 1 and table 2, they will go through the same step. All the values divide by 3.75 multiply by 4. Okay, all of them. This is the first step. Okay, we will not do the calculations now. We already done it. We have already done it for 3 examples last time, and even this step is done in some previous examples. So we are just repeating the concepts here. So I'm explaining you the procedure. So pay attention. So the first step is you convert all values of 3.75 hours to 4 hours. Then the next step is with the first table, okay, with the control count location. Okay, so in this table, after you do the first step, you will have the values without any gap, and all values will be 4 hours, 4 hours, 4 hours. Okay, all the values will be 4 hours. If you add the three values of one day, you will get the value for 12 hours, right? Each value is 4 hours or will become 4 hours. You will add them together, they will become 12 hours. Okay, and how many days you have? You have 3 days. Okay, so you will have three values each of 12 hours. Okay, so for the control location, I will have for each day a value for 12 hours, and for three I will have three values for 12 hours for 3 different days. So we will calculate the average then. Okay, so for the control location A, I will have average of 12 hours for the 3 days. Okay, now using that, are they given here? No. Okay, using that, we will calculate the adjustment factor and the expansion factor. Okay, so for example, for Monday, okay, if I'm going to calculate the expansion factor of 8 to 12, 8 to 12 is the first value. Okay, so you convert it into 4 hours, it became 3200. Okay, divide by the total of 12 hours for Monday. Okay, and the same thing will be done for 12 to 4 and then 4 to 8 as well. So for all the values we will have an expansion factor. Okay, so this is for the expansion factor. For the adjustment factor, you have the if I'm calculating, let's say, adjustment factor for Monday, it will be the 12-hour of Monday value divided by the average of 3 days. Okay, so this will give you the adjustment factor for Monday, and the same will be done for Tuesday and Wednesday. Okay, so you will have three adjustment factors, and for each day you will have three expansion factors, because each day has 3 periods, 8 to 12, then 12 to 4, and then 4 to 8. Okay, so you will have adjustment factor for each day, and you will have expansion factor for each 4-hour period. Okay, now the work with the first table is done. Now I move on to the second table, which is 1000, let's say 1900. Okay, so the first value is 1900. What do I do with this value? First of all, I convert it to 4 hours, right? So multiply by 4, 3 divided by 3.75. Okay, this will be 4 hours. Now this 4 hours is on Monday, and it will become 8 to 12 after filling this gap. After doing this step, this will become 4 hours, so 8 to 12. Okay, so I will since it is Monday, I will multiply with the adjustment factor of Monday. Okay, and since it is on Monday 8 to 12, I will multiply with the expansion factor of 8 to 12 Monday. Okay, so this after you do this step, this will become a 12-hour count, or sorry, an average count for location 1. Okay, this whole thing will become the 12-hour average count for location 1. Okay, and you will repeat the same step for location 2, but for location 2 the expansion factor will not be for 8 to 12, it will be for 12 to 4. Okay, it will be for 12 to 4 and so on and so forth. So you need to check the day and you need to check the time, and the expansion factor and adjustment factor will be according to that. Okay. So this will be done for all the locations. Now again, something which we did in lecture number 2, which was using the axle count to convert it to vehicle count. We are using pneumatic road tubes here. We did one example in lecture 2 where we used the pneumatic road tube count and converted it to number of vehicles. 1900 is this value of location 1, given value of location 1. Okay, so I'm converting the value of location 1 into 12-hour average count. For doing this, I will do this whole thing. Okay, so these are Excel counts. Whatever number you will get here after doing all this, this will be an Excel count, an average 12-hour Excel count. Okay, then I need to convert this 12-hour Excel count into vehicle count. Okay, we did an example like this in lecture number 2. So a table was given like this. The pneumatic road tubes counts number of axles. It doesn't give you number of vehicles because it counts how many times the tires are crossing over it. Okay, so if there's a truck, the 3 sets of tires will cross over the tube. So it is one vehicle, but it has 3 sets of tires. So the tube will counted 3 times. Okay, so how do I convert this Excel count to vehicle count? We are going to do the same calculation which we did for lecture 2. You have a manual count on the same location, okay, or one of the locations. I told you earlier these locations are representative of each other. So even if you did manual count on one of them, it should be enough, okay, if they are part of the same sub network. So we have the manual count here 1100, 130, 46, and these are the number of axles for each one of them. So we will add all the vehicle counts and we will add the number of axles in all these vehicles. Okay, and we will take the ratio. So yes, to get the yes. So how many vehicles we have? 1100 plus 130 plus 40 plus 6, right? And how many axles we have? 1100 into 2 plus 130 into 3 plus 40 into 4 plus 6 into 5. So how much did we get here? Yes, how much is this value? Or both these values? Okay, and if you take the ratio, then how much you get? 2780 upon 1276, how much you get? Okay, so now all the values you have got from the prior calculation must be divided by this number. Okay, so for example 11804, how did I get this number? I converted all these values to 4 hours, then I added the values for each day, and then I took out the average of these 3 values. Okay, so I got what? After taking the average, I got 11,804. If I divide 11,804 by 2.18, okay, I will get 5415 approximately. Okay, for location 1 we have to do this. Okay, so you have to calculate the expansion factors and the adjustment factors using the first table, and then you have to convert each count from the second table into 12-hour average using this. Okay, multiply by 4, divide by 3.75, then multiply by the adjustment factor, then divide by the expansion factor of the time and day. So after doing this I got 7566, and then I divide 7566 with 2.18 like I did here. Okay, and then you will get 3471. You can try this. The steps are written here, all the steps are written here. Okay, and there's no new step here, so I leave it up to you. You try it and you can see if you have any problems, you can let me know, and you can check your answers from here. Okay, the answers are here. So this is before converting the Excel count, this is after converting the Excel count. Okay, now we move on to another concept which is called as VMT, vehicle miles traveled. Okay, vehicle miles traveled is the product of length of the highway with the volume of the highway. Okay, multiply length of the highway with the volume of the highway, it becomes vehicle miles traveled. Now we know the length could be in kilometers as well. The length could be in kilometers as well. So if you are using the length in kilometers, then it is called as VKT, vehicle kilometers traveled. Okay, so in some countries they call it vehicle miles traveled, in some countries they call it vehicle kilometers traveled. Okay, but the formula is the same, length of the highway multiplied by the volume. Okay, now the volume itself, you know, volume can be hourly. In the example which we did now, the volume was 12 hours. The example which we did in the previous lecture, it was 8 hours. Okay, so the volume itself can be for different time zones. So the same thing will happen with VMT as well. If I multiply VMT, if I multiply volume of 8 hours for VMT, the VMT is for 8 hours. And if I multiply volume of 12 hours for VMT, then VMT is for 12 hours. Now if you look here, the example which is given here, these values are 8-hour counts. So at each location I am calculating 8-hour VMT. So count into length gives you VMT. And the good thing about VMT is you can add it for the entire network as well. So you can see I have 7 locations here, location A and 1, 2, 3, 4, 5, 6, 7, and they have calculated for each one of them, then they add it. So this last value 10,000 something is the VMT of the entire network. Okay, so why VMT is used? VMT tells you how much highways are used. Okay, what is the usage frequency of the highway? VMT is considered as part of the usage frequency of the highway. Okay, so VMT is higher, that means the highway is used more. If VMT is lower, then that means highway use is less, and so on and so forth. Okay, so this is a representation of VMTs, okay, or even volume as well, either the VMT or the volume. Okay, we call it the network flow map. It's a map of the area. You can see it's a map. Okay, the map is showing streets, and now you can see the size of the street is changing, right? The size of the street is changing. This one is smaller, this one is bigger, these are very small, this is somewhat small. So their size is depending upon their width. Basically their width is depending upon the VMT on it or the volume on it. So when I see in the network flow map a road is wider, I know it has more usage. If a road is drawn with the narrow lines, I know that the road is used less. And obviously, a road which is used less is normally a small street or something, right? So these will be small streets. These are big highways. Okay, and these are maybe collector roads or something. Okay, so this gives you a direct indication of which road is what. Okay, then we have, so we were talking about limited network study. Now we are talking about statewide counting program. State, for a country like Bahrain, state would mean the entire country. Okay, state would mean the entire country. If you are in UAE, then state could mean one emirate. Okay, so Dubai could be one state and so on and so forth. If you are in Pakistan, we have provinces, and even in Bahrain, we have what do we have? We have governorates, right? You call them governorates. But obviously, those governorates are also, according to the size of the country, on the smaller side. So, for Bahrain, even when the government is doing planning, they consider the whole governorate or the whole country as one state. Okay, but if you are doing it for, let's say, Saudi Arabia, then Saudi Arabia is a big country, so you have different provinces then, and you cannot you know merge them into one state. So this is the difference. But the point is, statewide program means counting program for the whole country or for a very big part of the country, either the whole country or for a very big part of the country. Okay, so it is similar to network programs, network limited network study, as because it has the whole network. You have to coordinate for the whole network. Okay, so it is similar in that sense, but there are a lot of differences between this and the limited network. The first difference is you are looking here for AADT. Okay, we are trying to find out AADT here. So who would tell me what is the meaning of AADT? What is the full form of AADT? Who will tell me?
Annual average daily traffic.
Yes, annual average daily traffic. So yes, okay. So we are looking for the in the previous examples we have done, we are looking for average of 1 day, 2 day, 3 day, something like this, right? But here we are looking for average of the whole year. And the average, you can calculate average of the whole year, but it doesn't mean that every month we have the same traffic. So traffic even changes from one month to another month, one season to another season. So we also take into account those variations as well, okay, in the statewide program. So this is the first difference between this one and the previous one. Secondly, again, something which is similar. So we have a difference now, and then we have a similarity. The similarity is that like we did for the limited network study, we do it for the statewide program as well. First of all, find out the classification of the highways. What type of highways you have and which highways belongs to which type. Okay, so the statewide programs always starts with the classification of the highways. Okay, so this is something similar which you have to do in both of them. Again, something similar is for each classification you will have control counts and coverage counts, right? So even in limited network study we are doing this. For each sub network we had control and coverage. Okay, yes, so these are two similar points. Then what are other differences between this one and the limited network? The other difference is limited network study is a one-time effort, but a statewide program is a continual effort. So limited network study, in the previous example we are discussing it for 3 days, right? It was a 3 day study. So after the 3 days are finished, you have the values, the end of study. But statewide program, you do ADT whole year once, next year you start doing it again. Okay, so it's a continual program, it's a periodic program. Okay, so this is another major difference between the two studies. uh, why we are doing it again and again? Because this is done by the government. Okay, so another difference between statewide and limited network is who is the client. In limited network, normally the client is the guy who has the facility, the owner of the hospital, the owner of the mall. But in this case, the client is the government, and the government, they need continuous data, right? They cannot relax that I have data for 2025, so I don't need in 2026. No, there are changes in the data, so they are interested in all the data they can get. So this is why it is a continual program. Okay, so if you consider the entire state of Bahrain, entire country of Bahrain, it has huge road networks which are in hundreds of kilometers or even more. So doing it for the entire kilometer for the entire road network is not possible. So normally after every 2 mile we set up a counting point, control or coverage. Okay, but even that can be very taxing. It can include lot of locations, even doing it after every 2 miles. So we exclude the less important streets from this count. What are less important streets? A guideline is given here. Streets which have less than 1000 vehicles in the whole day on average. So I'm not talking about a particular day. Okay, but on average throughout the year they have like less than 1000 vehicles in the whole day. So this is a very low number. So those streets can be ignored from the regular program. Obviously if you are doing some construction in that area, you are going to block the road and so on and so forth, so then you have to do a special study for that, but you don't have to include it in the regular studies which you are doing. So a lot of small streets, majority of the small streets are excluded after applying this rule, so it becomes much easier. Then in the limited network study, we saw the rule of the ratio of control to coverage locations. So there it was 1 to 10, 1 to 20, because we have a smaller network. Here the network is bigger, so we made the rule which can suit us. So 1 is to 20, 1 control to 20 coverage will still have lot of locations as control. So we have broadened the rule, we have made the rule more flexible. So now it is 1 is to 50. It can go up to 1 is to 50. So for every 50 coverage locations, I will have 1 control location. Just to remind you, control locations needs full count. Control location needs full count. Coverage needs a sample. So I need more samples and less full counts. Okay. But if I keep the ratio of 1 is to 20 for statewide program, even that will give me a very large number of locations for the full count. So I'm trying to minimize the number of locations with the full count. So I'm increasing the number of locations with the sampling count. Okay, now another difference between limited network and statewide program. Limited network has only one type of control, okay, the full count. But a statewide program has 3 types of control counts. You can have permanent, major, minor. Permanent means you have a permanent detector installed there and that collects data 24/7. Okay, so we have data collection from 1st January till 31st December continuously, no gap. That is called permanent control count. Then we have major control count where data is collected 1 week every month. Data is collected for 1 week every month. So it's continuous but not for longer time. And then we have the minor control count, which is 5 days every quarter. 5 days every quarter, 3-4 months. Okay. Anything which is less than this will be considered as a coverage count. Anything which cannot even fit the definition of minor is considered as a coverage count. Okay, so coverage count is normally 2 days or something like this, 1 or 2 days or something like this. I got this map from the ministry at one point of time, which is showing, just if you can see, they are just showing the counting locations on the major highways only. Um, already explained it. Okay. Uh, Now here we are going to discuss if you have data from control count locations, control counts, okay? How you calculate AADT from that data. The data could be of different types, okay? The control count data could be of different settings. So how to calculate the AADT from each setting. Now you see this one, this data for every day. So they collected data for the entire year. And the entire year we have the 7 days of the week, right? So what they did, they separated the data for each day of the week and calculated an average for that day. So whatever Mondays they had it in the year, they separated those Mondays, the data of those Mondays, and then they calculated the average from all the years of the from all the days of the year only for Mondays. Okay, and they got a value of 1820. Okay, and they did the same thing for Tuesday, Wednesday, and so on and so forth. Okay, so each value is an average for the entire year. Each value is already an average for the entire year. So but it's each value is per day. Okay, average per day for that day of the week. Okay, so first thing is we want to calculate the AADT. Okay, AADT is for the entire year, right? The average of the entire year. I already have the average of that day for the entire year. So if I want the average of the entire year, I will do the average of all the days. Okay, I'll do the average of all the days. So what is the average of these 7 days here? Tell me. You have 7 values. What is the average of these 7 values? Tell me. Yes, what is the average of this table? Tell me. Yeah. What is the average of these 7 values? Tell me. Okay, so this is your AADT. The value which you gave me is your AADT. Okay. Now, using this AADT and the average values of the days, I will calculate adjustment factor for the day. Okay. So like we did for the limited network, but the limited network for each day I had a single value. In this case, for each day I have lot of values and we calculate the average. So if I'm calculating average adjustment factor for Monday, it will be the average of Monday, which is 1820 divided by the AADT. Okay, got it? How much is this? I believe I wrote the equation reverse. Okay, sorry for that. No. The equation is actually this one. 1430 divided by 1820. The ADT is on the top. Okay, so how much you get here? What is the inverse of 1.27? How much? 0.786. Okay, so this is the adjustment factor of Monday. Okay, and for Tuesday, just because we had this confusion, the adjustment factor will be the average, the ADT upon the average of Tuesday. Okay, so the adjustment factor is inversely proportional to the average of the day. So how much is that? Okay, so this is how you will calculate the adjustment factors for all the days. Okay. You want to be more precise. Okay, so now we can see the plot of these adjustment factors. Okay, the ones which you were giving me. So you can see the 0.9 here, 0.786 here, and so on and so forth. Okay, and since the adjustment factor is the inverse of, oh sorry, the adjustment factor is inversely proportional to the traffic. So when the adjustment factor is higher, that means the traffic is getting lower. So the lowest traffic is on Saturday. If you look here, lowest traffic is on Saturday. And the factor is the highest because the factor has the traffic in the denominator. Okay, so when traffic is higher, factor gets lower and vice versa. Okay, so it's the other way around. When traffic goes higher, factor is getting lower. Now this is another set of data where you don't have averages, you have totals, and the totals are for the months. Okay, so first of all, the first value is the total of the January. It's not the average of January, it's the total of January. The second one is the average of February, not the the second one is the total of February, and so on and so forth. So if I want to calculate AADT here, okay, I will take the sum of all these months. Okay, now remember these are not averages, so I will not do sum upon 12 because each number, so this 19,840 is not the average of January, so it's not single value. It is a sum of values for all days in January. Okay, so I will not divide by when I sum the values of this column, I will not divide by 12. Okay, because these values are not per day, these are per month. Okay, so if I divide by 12, I will get volume per month. I want ADT, which is per day, daily. Remember, ADT is average annual daily, right? So when I sum all the values, I divide by 365, the number of days in all the months. Okay, because this is total traffic. If it was average, then I will divide by 12 and I will get the ADT for the whole year. So if you add all these values and divide by the number of days, 365, what do you get? $797. Okay, so this is your AADT. This is your AADT. Okay, now if you want the adjustment factor for January, okay, so adjustment factor for January, so I will take AADT like I did earlier. Now I have to divide by the daily average of January, okay, not the total. You cannot divide daily average with the total of something. Okay, so you have to divide by the daily average of January. Okay, so that value in January is 19840. Okay, put the bracket here, big bracket. Okay, divide by the number of days in January. Okay, number of days in January I believe are 31, right? So this will give you the adjustment factor of January. Okay, if we are doing it for February, okay, then it will be 797 divided by what is the value in February? 16660 divided by the number of days in February. Okay, so this will give you the adjustment factor of February. Okay, got it? Anyone has any questions? Okay, again the plotting of these factors, the adjustment factors. So February has the lowest traffic, so it has the highest factor, and vice versa. August has the lowest factor and the highest traffic. Okay, now this example is very complex, so please pay attention. First of all, you see two sets of data, not one, and both of them are not continuous. The first set of data is only for 4 months, and in each month the data is given for 7 days, 1 week. Okay, and the second table has data for all the months but only taken in 1 week, and the data is an average value. So this 2250 is the average of third week of January. This 2200 is the average of third week of February, and so on and so forth. Okay, so data is not complete. I don't know the data for all the days or all the weeks. Okay, and the data is not for even for the total of the months. Okay, so I want to calculate AADT here. Okay, so for AADT, I will add all the traffic for the whole year and divide by the number of days in which the traffic was taken. Okay, so I need to know the total traffic of the whole year which was observed and divide by the number of days in which it was observed. So if I look at table number 1, uh, I have 7 days 4 times. Okay, so I'm calculating the days now. So days is 7 into 4. This is coming from table 1 plus, okay, the number of days for which the data was taken in table 2. So table 2 I have 12 values and each value is the average of the week. So again 12 into 7. Okay, so this will give you number of days in which the data was taken. So how much is that? Okay, the data is taken for 112 days. How much taken traffic is taken in 112 days? All this is taken in 112 days, right? This entire traffic is taken in 112 days or part of the 112 days. And all these values are taken in those 112 days. But each of these values is an average. Okay, so I cannot take an average and then again divide by number of days. So I need to convert this average into total. Okay, so you know average is total upon number of days. So if you have average multiply by number of days, you will get total, and this is what we are doing here. So table 1, each value is already for 1 day, so I can divide by the number of days. And here each value is an average of 7 days, so I multiply by 7 to get the total of these 7 days. So table 1, all values 1 by 1 plus table 2, all values multiply by 7, then add it. Okay, and then divide by the number of days for which the values are taken. Okay, so this will give you AADP. Okay, uh, can you give me this value? And if you have any questions, please go ahead. Yes, can somebody give me AADT here? Yes, ADT, anyone? What? Explain again. 112. ADT is total traffic of the year observed divided by the number of days in which the traffic was observed. I have 28 days here, okay, and each value is one for 1 day only. So I will add these values plus the values which are in table 2, but these values are already an average. You can see it over here. So each value is already divided by 7. So if I take these values and again divide by 112, which has the 7 days, it will be double division. So I cannot do that. So each value multiply by 7 to make it into total. Okay. So all the values from table 1 plus each value from table 2 multiply by 7, then divide by 112. Okay, 112 is the number of days in which all these values were taken. Okay, 4 weeks here and 12 weeks here. Okay, so in order to convert these values into the total of the days, I am multiplying it by 7. So now can you do this? Can you calculate ADT here? Okay, so this is your ADT. Now I want to calculate the adjustment factor for each day and each month. Okay, so let us start with Monday. Okay, so Monday, if you look at table 1, Monday has 4 values. Okay, so what is the average of these 4 values for Monday? Tell me. Okay, so if I want to calculate the adjustment factor for Monday, it will be the ADT divided by the average of the Monday. Yes. Okay, and you will get the adjustment factor for Monday. Okay, almost one. Yes. And if you want it for the Tuesday, then you will do the average of this column and then ADT divided by the average of this column. Okay, and so on and so forth. So this is for the days of the week. Now if you are doing it for the month, okay, if you are doing it for the month, now for, let's say, if you pick January, now January has values of 7 days here and 7 days here. Okay, so I need to add these values. Okay, so I will take the value of January from table 1 and take the value of January from table 2, multiply by 7 again to make it into total, because this is an average. Okay, so for January I took 7 days from here and 7 days of values from here, so 7 plus 7, total of 14. Okay, so for January the total will be table 1 for January plus table 2 for January multiply by 7. Okay, the reason for multiplying by 7 is the same as what I said earlier, that you need to convert the average into total. Okay, and and then you will calculate the average of January as January total divide by 14. Okay, 7 days here and this is for 7 days as well, a week. Okay, so that's why divide by 14, and Bayan is saying it is 2032. Okay, so the adjustment factor for January in this case will be 1958 divided by 2032. Okay, okay, then for February, Okay, now pay attention. February, do I have February in table 1? No. Okay, there is no extra data for February. Now the value for February 2200 here is already an average. Okay, the data is taken for 7 days and I have the average of 7 days. So nothing to be done for February. Okay, the average of February is 2200. Okay, no extra data, so nothing to take average again. For January there was 2 data sets, so I had to take the average again. February, no problem. Okay, so February adjustment factor will be 1958 divided by 2200. Okay, so how much is that? Yes, so the same will be repeated for March. For April, you again have to take it from both tables. For April, July, and October, you have to take it from both tables. For the remaining months, you will only take it from one table, which is table number 2. When you will directly take the ratio, no need to take the average again, because for the rest of the months, they are already average of the week. The data is only taken for a week, and you have the average for that week. Anybody have any questions? Okay, everything is clear? Okay, these are the values. You can calculate them and you can check them. Okay, in this example, this is example for 1 point of data, 1 control point. This is an example for 1 control point. This is an example for 1 control point. Okay, now we are talking about a statewide program, right? We are talking about a statewide counting program. So obviously we will not have 1 control point. We will not have 1 control count. So for every control count, we will be calculating these adjustment factors. So if I have 10 control counts, I will have 10 sets of adjustment factors. For each control count, I'll calculate monthly adjustment factor and daily adjustment factor like you did in the last example. So I have 10 factors for Monday, 10 for Tuesday, 10 for January, 10 for February, and so on. 1 for each control count. Now more factors means I need to keep more data, and when I'm going to use it, I will show you how to use it. When I'm going to use that data, I have to deal with more values. So if somehow I can reduce the number of values to deal with, my life will become easier, my analysis will become simpler. So if somehow I can combine the data from 10 or 20 or 30 points, I can combine them, it will be much more beneficial for me. Okay, now combining means I want to take an average. Instead of 10 values, I want a single average value. Okay, so for Monday I have 10 values or 20 values, I will combine into a single Monday value. For January I have 20 values, I want to combine into one single value. Okay, so combining means taking an average. Okay, and we are trying to combine the adjustment factors, and the adjustment factors are only coming from control locations. So we are talking about grouping or combining the data of control locations, and that data is the adjustment factors. Okay, so there are rules to be followed here. Okay, when you are doing this average, so you cannot just simply take all the points in your area and combine their factors and say okay, I will go with it. No. For example, we have a data point where the factor is 2, and we have another data point where the factor is 0.9. Now you can see there's a lot of difference between 2 and 0.9. If I take their average, I am not close to 2 and I am not close to 0.9 as well. My value is wrong from both the points. Okay, if I'm close to 2, then at least I am more accurate to the first point. If my value is close to 0.9, then I'm more accurate to the second point. But if the points are very far from each other, the values are very far from each other, then average doesn't make any sense. Okay, it's like I take the grade of an A grade student and an F grade student. I take the average and say the average grade was C. Obviously it was C. Okay, because one is F, the other one is A. So every time I'll be getting C. Okay, but the fact of the matter is none of the students got even close to C. Okay, the A is far from C and the F is also far from C, right? So taking average of values which are far from each other doesn't make any sense, doesn't fulfill any purpose. You are actually destroying your data. If you took them one by one, you are accurate from all accounts, but if you are trying to combine them, we will combine those factors which are close to each other. So there is a rule given for deciding if the factors are close to each other or not. Okay, and the rule is the last point. When you take the average and the difference between the average and the factors, individual factors, is less than 0.1, then we consider the factors to be close to each other. Let me show it to you with an example. Here we have data from 4 stations, and from each station the factors are calculated for each day of the week, the adjustment factors. So the factors which we are looking at in the table are adjustment factors for each day of the week. I am trying to combine the data from these 4 locations. That means for each day of the week, I am trying to use an average value. Instead of 4 values, I'm trying to use one single average value. So in the last column, you see the average value which we are trying to use in future. But before deciding or before selecting this average value, instead of the 4 values, I must apply the rule. The rule was the average and these values should not have a difference of more than 0.1. So if you look at the average value 1.01, if you look at the value of Monday for station 1, it is 1.05. If you take the difference, you will get 1.05 minus 1.01 will give you 0.04. Okay, so it is less than 0.1. Okay, so this factor passes the rule. The second one is 1.01 and 1. So 1 minus 1.01 gives me 0.01. Again, it passes the rule. If I go for the the third value, 1.06, plus and minus doesn't matter. Okay, plus and minus doesn't matter. You're just looking at the value. So this will give me 0.05. So again, it passes the rule. If I look at the last factor, 1.01 minus 0.92. Okay, so this is 0.09. So again, all these values pass the rule. Okay, all of them are less than 0.1. So for Monday, I have no problem. If I go for Tuesday and I apply the same rule, okay, so 1.02, 1.1, okay, the answer will be less than 0.1. 1.02, 1.02, no problem, answer is 0. 1.06, 1.02, the answer is 0.04. What about this one, 0.89 and 1.02? Okay, the answer will be more than 0.1, it is 0.13. Okay, so this one violates the rule. Okay, so what I'm going to do is I'm going to make they've already made it bold, but I'm going to make my own mark here. Okay, so this value violates the rule. If I look for Wednesday, 0.1, 0.06, 0.05, 0.06, 0.11, 0.06, 0.97, 1.06, again all of them satisfy the rule. Thursday, no problem. Friday, you can check these values one by one at your own time. I'm just going quickly through them. On Saturday, this is where we have most of the problems. We have 0.98 and 0.85. So this one violates the rule. 0.98 minus 0.85. This will give you 0.13. Okay, so this one violates the rule. Again, I will make my own mark here. Okay, 9894, no problem. 998, no problem. 1.2 and 0.98, big problem. Okay, so if you take the difference of them, you will get 0.23. Okay, so I'm going to make a mark here. Okay, now who can tell me which value on Sunday has a problem? Tell me. On Sunday, there is one value which has a problem, which is not fulfilling the rule. Which value is that? Yes, which is for location 4. Sorry? This one, right? This location has a problem. Okay, so now you can see I have marked 4 values here which do not fulfill the rule. So can I combine these 4 stations with these 4 values not fulfilling the rule? The answer is no. If there were not 4 values, if there was only one value, the answer will still be no. Okay, so for the combination, it is important, or it is a rule, it is a must, that all values must fulfill the rule, all of the values. Okay, for all the days and all the months and everything. So it's not doing this, so the rule is not fulfilled. Okay, and even if it is not fulfilled for one value, it is enough to say no, we cannot combine these 4 stations. So now the question is, what would be the next step? The next step is pick one location, one of the points, one of the columns to be excluded from the data, and do the next trial with the remaining locations. Okay, whenever you have a situation like this, you try to combine, the rule was violated, you decide in the end which column or which particular location can be taken out from the data, and I can do the trial with the remaining locations. Okay, I have location 1, 2, 3 and 4. Okay, if you look at the points at which I make the mark, I made the values at which I have made the mark, most of these values belong to station 4. Most of these values belong to station 4. So if I remove station 4, I have more chances of being fulfilling the rule with the remaining values, with the remaining stations. Okay, so we will bring out station 4. Okay, so let me put a cross here. Okay, so station 4 is not included now. So we will do the next trial with the remaining locations. Okay, location 1, 2 and 3. Okay, so can you start calculating the average for each day for the remaining 3 locations? What is the average of Monday and Tuesday and Wednesday? Okay, so Monday is 1.04, Tuesday is 1.06, Wednesday is Wednesday is what? 1.09. Thursday is what now? 0.86. And what about Friday? What is the value for Friday? One 1.02. Which one? Thursday is how are you taking the average? This is Thursday. 1.06, 1.06, 1.03. What's the average? Even for Thursday, 0.86 cannot be correct. No, how? 1.06 plus 1.06 plus 1.03 divided by 3. How much? 1.05, yes. Okay, Friday 0, 1, 0, 3 and 0, 0. What's the average? What's the average of Friday? 1.01. Okay, Saturday. Now this one will be less than 1. 0.859499. Okay, 0.9. Okay, Sunday 839 and 0.84. 0.86. Okay, now we can check these values with if they are fulfilling the rule or not. Now Monday we have, now you see, since I crossed out column 4, in the remaining columns I had only one value which had a problem. I deleted it, I shouldn't have, but there was only one value which had a mark. Okay, so when you crossed out column 4, in the remaining values only this value had a problem. Other values were already fulfilling the rule. So if this value fulfills the rule, then my work is done. I know other values are by default fulfilling the rule because they did not have any problem even with the combination of 4 as well. Okay, so if there was no combination, if there was no problem with the other combination, then there will be no problem with the new combination as well. Okay, so 0.85 and the average for Saturday is 0.9. Okay, so 0.85 and 0.9, I will get 0.05. Okay, so this one also fulfills the rule. Okay, so that means all the values are now within the range, and instead of combining, so what will be the next step? The next step will be, in the remaining calculations, whatever calculations I'm going to do after this, I will use average values instead of a single value for station 1, 2 and 3. Okay, so I will have one set of values for these 3 stations combined, and I will have a separate set of values for station 4. So station 4 will retain its values, and the other 3 stations, for all the stations, the values will be replaced by the average, the new average which you calculated. Okay, any questions? Okay, it's clear.